Alright guys, so this is the video over exponential functions, and I know you can't really see them here, but exponential functions look something like this, where they go through 0, 1. Okay, oops, you can't see that. And really we're going to name some characteristics here. So again, limits are here are the values, the y values for at a certain x. So here the x is negative infinity, so it's somewhere way over here. And here the y value here is 0. It doesn't get lower than that point. And for the infinity, it is the y goes all the way to positive infinity. Okay, so this is really important because the limits here, there's an asymptote happening here, and I don't get lower than that point. And really, when I'm starting to do shifting, either up or down, this is what moves up and down. Okay, and so I do have a y-intercept. It's at 0, 1. I do have an increasing and decreasing. Excuse me, I am increasing in this whole thing. So from negative infinity to positive infinity. Decreasing from, well, here I don't decrease. I don't come back down, so none. I am bounded on the bottom. And this is a neither function. Okay, so it's not. It doesn't have any symmetry. And so, as I go through these guys, just so you can see here, this problem right here, this is 4 to the power of x. And you know what, let's do another problem here. But y'all can see what's going on. We'll do this one here. So, you know what, let's do this one. So, here, just so we can describe everything that's happening here, is a function that's base of 3. So this is a growth function, but the negative here means it is decaying. So we can go through that real quickly. So remember, when I have an equation, my a value, b value, c value, and d value do different things. And so what I have here is an a value. When I'm dealing with, let me write this off to the side. When I'm dealing with an exponential, you're going to have some base number. That's what this base is. Anything in front is a. Anything in front of the x in the exponent is b. And c over here, still in the exponent, and values for d, which move this up and down, is going to be outside of that. Okay, so we're going to use our same rules, these right here. And so I do have a negative with the b. So here, a negative with the b means I reflect across the y-axis. So we're going to go ahead and do that, reflect across the y-axis. Okay. I do have a value for a, so it's also stretching in the x direction. Okay, excuse me, in the y direction. Let's not say that. In the vertical direction. Okay. And the a value here is 2, so it is by a factor of 2. Okay, so usually my exponentials look like that, but since I am reflected across the y, now it's coming down. So this is a decay function. So it's coming down, and I don't have values for d, so I'm not moving this up and down. Okay, so the asymptote will stay at 0. Reflect across the y-axis, so like I said, I'm coming down. And really, that's the basic shape that we need. Okay, and so anything more difficult, you will have the calculator for, which we'll talk about over here in the word problems. So here I can see that at negative infinity, my y value is infinity, and in this case my f of x is 0. Excuse me, and positive infinity, my y value is 0. Y-intercept in this case has stayed the same, has not moved. This is a decreasing function, so from negative infinity to infinity, it is decreasing with no increasing. It is still bounded below. And this is a neither function. It is not, has no symmetry. Okay, and so this is going to be the big one for the test, guys. And so different things I can ask. Again, I did make a mistake. This should be negative 0.2t. Okay, so new cars bought, and the depreciation in thousands is modeled with the function. So we have a function that looks like this, and we're going to go ahead and, if you graph it, that's what it would look like. Okay, again, because of, I'm going to rewrite this as 30e negative 0.2t plus 15, because I just like having this number out here in at the end. So I have a value for a, for b, nothing up here in the exponent, so no c, and this is d. So really what happened here is I am having a horizontal stretch, because this is between, the b value is between negative 1 and 1. And remember, I want the reciprocal, so I can also write 0.2 as 2 over 10, okay, but if I want, let me write to the side. So 0.2 is 2 over 10. So I can write it over here as 10 over 2, which again I can simplify as 10 over 2, the reciprocal of 2 over 10, as 5. Okay. I also, because I have a negative sign reflected across the y-axis, okay, an a value, so I'm also stretching, okay, a value, and it's bigger than 1, so I'm stretching vertically by a factor of 30, and value for d means I moved up 15. Okay, so when I asked for the transformation, that's what I was putting there. Okay, so what is the initial value of the car? What did you pay to get this car? And so here, guys, I mean, the time is equal to 0, so all I have to do is, this is my equation right here, I plug in a 0 for t. So 30e negative 0.2 times 0 plus 15. So I'm going to go ahead and put that into my calculator over here. So I paid 45, not just 45, but I paid 45. Remember, this equation is in thousands, so I paid $45,000 for this vehicle. Okay, and here, when will the value reach 20,000? So again, guys, here I'm dealing with thousands, and since my equation's in thousands, I want to know. I'm given a price, and I want to solve for time. I have an equation here, so I'm going to go ahead and solve that equation. And I'm going to use nsolve for this. So it'll take me 8.95 years for the value of the car to reach 20,000, which, I mean, if we are dealing with like a real car, 9 years from the time you bought it to reach a $20,000 price, that's pretty good. So these are type of problems you'll have calculator for. So go ahead and study, guys, and we will see you all in class.